Hey guys, how's it going? The video for today is a coming together of watching more than 10 hours, a ton of conference talks on Node.js internals, V8, the event loop, and trying to distill all of that into a short video. I also read source code, which I'm gonna show you a little bit, and I read a lot of articles. Everything that I've watched and read is gonna be linked in the description below. So the idea for the video is, if you already know what Node.js is, because I'm not going to explain what it is, if you care to know a little bit of the internal parts of it, not with an immense amount of detail, but sort of like all the pieces moving together, that's the point for this video. So let's get started. The first thing I want to say is that Node.js is the coming together of three major aspects. It has a JavaScript runtime. It's usually V8. You can use a different runtime, but this is like the engine, the virtual machine that will run your JavaScript. It has an event loop, which is Libuv, and it's in charge of handling file system access and networking and the asynchronous operations and concurrency, the concurrency model. So we'll talk a little bit more about that. And then it has an standard library, because there are a lot of APIs that Node.js has to provide you with that are not for the browser. So there are other aspects, like all the code that sort of integrates everything, and the Node C++ API and things like that. I'm not going to cover that. So first, let's talk about some misconceptions. Node.js is single-threaded. And the problem here is that it depends what part of Node.js. Like, not all of Node.js is single-threaded. The event loop and V8, they run in a single thread. So you have a single main call stack, and we're going to see that now. But the idea is that your code, your execution context is single threaded. So your JavaScript code will always have a single call stack, and it will run in a single thread. So if you block if you run a very expensive operation in your JavaScript and you don't take that into account, you might block the loop, and then all hell breaks loose. But so it is single threaded and is not, because there's also a thread pool, and we'll talk about that just now. So the second misconception is Node.js uses a thread pool for all input output, and because threads need to be blocked while you're reading to a socket or reading from a file. The reality is that Node doesn't use a thread pool for a lot of things. It uses a thread pool when there's no operating system asynchronous API that allows you to do non-blocking input-output, right? So for instance, if you're in Unix, when you're reading from the file system, there's no good, at least so far, operating system syscalls that will let you just operate on files concurrently and have non-blocking operations. And so for that, Node.js will use a thread pool. It will also use a thread pool for a couple of DNS operations and for some crypto methods like random bytes and the PVKDF2 algorithm. But whenever there's an operating system syscall or API that lets you use non-blocking input-output, Node will use that instead of the thread pool. So for instance, if you want to do networking and things like that, you don't need a thread pool for that. So it's not true that you need to block your thread in order to do input-output. These two misconceptions go together, because on the one hand, you have people saying Node.js is single-threaded, like it's just single-threaded, and that's not true. On the other hand, you have people saying, well, you use a thread pool for everything. And that's not true either. So it's kind of like in between those two. The third thing is that you have the event loop running over here in one thread, and then JavaScript running in a separate thread. And that's not true either. Like the same thread will sort of like run everything. And then you have the setimmediate and process.nexttick. We'll talk about these two later on, but the names are switched around. So nexttick, people tend to think, okay, whatever I put in here, passing as a callback here, will run in the next tick of the event loop. That's not true. It will run immediately. We'll see what immediately means. It's not kind of quite that immediate, but pretty much. And setimmediate runs in a specific phase of the loop. So it'll run on the next tick of the loop. So if you could switch those around, that's what they mean. And the last one is that Node.js uses the reactor pattern, which is true and false, like the event loop and the whole under the hood way of working is inspired heavily by the reactor pattern, but not quite. Like I said, sometimes Node will not delegate to worker threads some operations, like some networking operations, or whenever you can do something without blocking, Node will try to do that. Libuv will try to do that. We'll talk about that just now. But so before we delve into what is an event loop and what's the point of it, you should know that there's a model in which you have a thread per connection. If you're writing a web server, for instance, something you can do is whenever a connection is made to your server, you could spawn a new thread or grab a thread from a thread pool and let that thread handle the new connection, right? So that thread will just be responsible for this connection from beginning to end, and it will block if you need to do input output or whatever. And then whenever the connection is done, you release the thread or you destroy it or whatever. The problem with that is that sometimes a thread can be fairly expensive. And on modern hardware and operating systems, you can run thousands of threads, and you can do that without issue. But it doesn't scale as well because you have a lot of threads going around. If you have, of course, a lot of concurrent connections, which is not the case, by the way, for most startups. But there's another model in which what you do is you actually have a thread that is going on a loop. It's literally a loop, and I'll show you the source code. And it checks for certain things and then tries to go around that loop. Hey, is there a new connection? Hey, is a timer expired? Hey, is there new incoming data? Whatever. And it will run some code in that main thread, and if it has to block, it will delegate to a worker thread, right? Or it will use a non-blocking operation from the operating system. But the idea is you don't block that main thread, and it keeps going. So this is like how it works inside. And here's again an example of diagrams that I tell you, like I said in the beginning, there's a bunch of diagrams that are fairly misleading. And that's why I did so much research for this video, because I didn't want to replicate these mistakes, right? But the idea that you get from this diagram is that whenever you have new tasks, they are thrown off to worker threads, which is true for a subset of the input-output operations. It's not true for some networking operations or, well, there's actually a few good examples of when it's not true, but it might be true for file reading if Unix does not provide a good enough non-blocking API. All right, so let's move to the JavaScript runtime. V8 is in charge of all things JavaScript, parsing, interpreting, compiling, optimizing your JavaScript. It's a JavaScript virtual machine, so it's kind of like, the JVM for Java, where JavaScript will be just-in-time compiled, be interpreted, and it will be optimized if it's code that runs all the time. It has a stack, it has a heap, and internally V8 has two main engines, which are Ignition and Turbofan. So I stole this diagram from this website that I link here, and you should check it out. I think the author is also looking for a job. But the idea is this is the call stack and this is the heap, right? So as you run functions, you push the function into the stack and it grows, right? It's put new operations there and they pop as they finish the functions. And whenever your call is empty, it's like you're done, right? So the heap is also where you allocate larger objects for memory that's not, global and that you want to hang around for a while. I'm not going to go into the stack and the heap and the architecture of virtual machines. This is not the point of this video, right? I stole this information from one of the videos that I saw that I thought it was a very good summary. But basically, V8 inside has sort of two engines that collaborate with each other. So they have Ignition and they have Turbofan. And they are good for different things and they sort of complement each other in the way that they work. So Ignition it has a very first startup, and it produces bytecode quickly, and is able to run your code without a lot of optimization, right? But it doesn't have to warm up or anything. Like, you just throw code on it, and it'll try to run it as fast as it can. And it's best for code that is executed at page load and code that you don't run all the time, because like I said, it doesn't do a lot of optimization. It's mostly an interpreter, and we'll see sort of what that means just now. But then you have Turbofan. Turbofan is like the complement to Ignition, and it produces very fast machine code, and it does assumptions on the code that allows it to optimize the code. And is best for code that is executed after page load and code that is executed very frequently. So the way that it works is that if you look at this diagram, and I stole most of this information from a talk that I watched, from a couple of talks. They'll all be in the description. But the way that it works is V8 will take your JavaScript source code, it will run it through a parser, and it'll produce an abstract syntax tree. That is like a tree that represents your program. And I'm planning a video in which I'll show you what an abstract syntax tree looks like. But basically, imagine that once you parse your source code, you have like a tree where the node is like assignment and the leaves are variable A, value 3, and things like that. It'll just model your program as a tree. And then that is fed to Ignition, which will interpret it. And every now and then, Ignition will realize, hey, this code is being executed a lot. You're running this function a lot. So maybe we can optimize it. And it will talk to Turbofan, and it will say, hey, this function is usually called with these types, because remember that JavaScript doesn't have, it's not a strongly typed language, right? So you can say var a or let a and assign it a number and then a string and then an object. You don't have a limitation that you have in Go or Java, right? So Ignition will talk to Turbofan and say, hey, this function is usually called with a string, and Turbofan will produce machine code that is going to be very optimized for the way that your code is being used. And every now and then, that's the green arrow here that produces optimized machine code. But every now and then, maybe you call this function like 100 times with a number. So V8 produces very optimized machine code for when that function is called with a number. And then you call it with a string. And Turbofan will realize, hey, my optimized machine code doesn't work here because it's meant to receive a number. So it will de-optimize and go back to the bytecode and go back to Ignition. So there's like this cycle that hopefully you're not going multiple times. And so here's where I get into tips for better performance. It's better if you treat JavaScript as if you were a type language, right? So the more that you sort of are consistent in the way that you call your functions with the same types and everything, that is best, right? And I give you an example here. Let's say that if you're always passing to a function an object with A and B as fields, and then you have an object in which you just have A5, like A with a value 5, it might be best to pass in a B with undefined because to always pass in sort of like the same structure of object. Because JavaScript will, I don't have time to go into this, but V8 will sort of create types under the hood of, hey, this object usually looks like this, and this object usually look like that, and we'll optimize for that. So if your objects and your types are always changing, and they're always kind of mutating and being different, it's hard to optimize for that. Another thing is what they call a holy array, so which is best to avoid if possible, right? But the idea is, imagine that you have an array with 3 elements, and then you just decide to assign at position 10, well, 11, index 10, you assign an 8. What do you think happens? It won't error out. It will let you do it. And now your length here is going to be 3. And that's going to be 11, right? From 0 to 10. But in the middle, you're going to have holes, right? Because what's at position 5 or 6 or 7? Nothing. It's a hole in there. And it's best to avoid that. There's a talk that I found really interesting on how V8 under the hood will sort of tag your array and say, hey, this is an array of small integers, right? And this is an array of strings. And but if you put it, if you have, like, say here, you have a bunch of integers, and suddenly you add a double, the type will sort of change and will go from more particular to more general. But it can't go back to more particular if you remove that double. If you have all numbers and then you add a string into your array, it will go from a more particular type to a more general type of array. But if you remove the string, it's just going to stay as general, even if you just have small integers. So it's best to avoid that stuff. And there's a whole talk on this matter. I'm not going to go too deep into it. And here I'll give you an example. Look at this function here, x to x plus 1. What do you think the machine code or the code for this is? Well, you will, in assembly, it'll ultimately look like an add operation, right? X plus 1. And that's kind of true, but the problem is, what is plus here? And you might say, well, it's obvious, you're adding 1 to x. Well, that depends, because what if x is not a number? If x is a string, you're concatenating, you're not adding. So when you look at the code that Ignition has to run, Ignition will look at this and will say, we'll run the spec, right? There's a lot of code for this. It'll say, well, is it a number? Is it a string? If it's a string, you have to concatenate. If it's a number, you have to add. And there are all these rules. There are a lot of rules in the JavaScript spec. Whereas, let's say that you call this function 20 times, 50 times, and you always pass in a number here. Ignition can then talk to Turbofan and say, hey, Turbofan, pass in, this is usually a number. Just treat it like a number and just check first, make sure that it's a number. And Ignition will produce very optimized machine code, and that's how JavaScript is able to run faster. Element kinds is what I was talking to you about, the arrays. I'll link to a very good talk on that topic. But yeah, this is as far as I want to get on with V8, right? There's a lot more to talk about, of course. Now, V8 does not implement a lot of web APIs or a lot of functions. It's just a JavaScript runtime, right? So you need Libuv, which is a library that provides you with a couple of things. I list them here. And this is where your event loop implementation is Libuv, okay? So it has an event loop, but it's not just an event loop. It has handles, which are a representation of a resource, file descriptor, a handle to a socket, things like that. It allows you to do requests, for instance, to write to a socket or that kind of request of input-output or things of that nature. And it has some utilities like timers, loop watchers. It has a thread pool, it has signals, and it sort of offers you an abstraction over the operating system so that you can write like code for multiple operating systems, just dealing with a higher level abstraction. So event loop is a loop. I'll show you the source code just now, but it's basically a loop that has multiple queues and it goes through them every tick. So the way that it works is it goes through phases. So first we check if we're alive, and that means many things like, do we have any active handles, or is there any request, or is a connection closing? Like, do we have anything to do, basically? And if it's alive, it will update the current time at the beginning of the tick. It will say, grab the system time and say, this is now, right? And then it'll go through timer handles and say, hey, is any timer expired? Like set timeout or something? Is anything expired? And then fire it. And the timers are stored in a min heap, so you can quickly retrieve the next timer that is due. So your set interval, set timeout, they would execute here. Then it's going to go into checking a queue for all pending IO callbacks. Yeah, if you're doing input outputs, some of those callbacks will go here. Then idle handles and prepare handles, they are executed. This is internal. You're not going to be using this. Your code is not going to be run on these phases. Node might choose to run something here. Then what you do is, before I/O, you run the prepare handles, prepare for I/O handles. Again, maybe internal to Node. And then you block for I/O, right? And how long do you block for I/O? Well, it depends, right? I put some conditions here, but if your loop is about to finish, you don't block for 0 time. If your loop is not alive, then you block for 0 milliseconds. Then if you have any idle handles or closing handles, you don't block because you want to run those. And then if you don't have any of these things, it depends how long you block, right? So if you have a timer that is about to expire, you block until that timer is due. So you're going to be waiting for I/O, and it's using, I think, if you're in Unix, I think this is using epoll under the hood. And we could make a separate video about syscalls and epoll and select and poll and these sort of things, but it's not worth it here. Then after you block for I/O, you run your check handles, which is, for instance, setimmediate. Your setimmediate callbacks are put here. So it's like you prepare for I/O, you block, and then you write your check handles. And then any closing callbacks, like for instance, if you close the file or if you close the socket and you have a callback for it, it's gonna run here. And then it just goes again on a loop, right? And it tries to run all those things every time. So let's look at some source code for this. I have the Libuv is open source, of course. I'll put the link in the description. But if you go to the Unix, we're looking at the Unix version. This is the run function for the loop, right? And as you can see, there's a while loop. So R is the loop alive? So while the loop is alive and there's no stop flag, update the time, run the timers, run the pending callbacks, run the idle callbacks, run the prepare callbacks, then calculate for how long you're gonna time out, how long you're gonna block for I/O, then you block for I/O, then you update metrics for idle timeouts, then you write your check handles and your closing handles, and then you check here for some checks to see if you need to break out of the loop. But if not, you just go back to the loop up here. And up here. So you just run again in this while loop. So as you can see, it's a while loop, right? That's what the event loop is. It just has separate queues, right? So it's not like you have a single queue where your timeouts and your callbacks for promises and your callbacks for they all go into the same queue. No, you have separate queues and you have separate phases within Libuv for every tick of the event loop. So then you have nexttick and microtasks. In what phase are those run? And the reality is that they are not run in any phase. Like there's your process.nexttick does not run, is not constrained to any of these phases. Basically, they run when you cross the boundary between JavaScript and C++. So when your call stack is empty and when it unwinds, you run microtasks. And your promise.resolve then will run there. Your process.nexttick will run there. So it's very immediate. So because you could be crossing from C++ to JavaScript in it, you will cross it here if you have a timer. You'll cross it here. You'll cross it here. You'll cross it here. So whenever you come back to C++, process.nexttick. So it's very immediate, right? Whereas your setimmediate callbacks will run in this phase, in check handles. So if you set one here, or you set a setimmediate here, or you set a setimmediate here, it will just, on the next tick of the loop, when it gets here, when it gets to the check handles phase, that's when it will run, okay? All right, so that is microtasks, but why that behavior? And I had a very good long explanation, but I realized that the video was gonna get extremely long, so I didn't include it. But maybe sometimes you wanna execute things once all your JavaScript is done, right? Before you go to the event loop. All your JavaScript finished executing, you just wanna run something in there. And that's nexttick is very good for that, because that's exactly when it's gonna trigger. Or maybe if you wanna run something before you let the event loop proceed with iteration. So the event loop is about to resume, going around, ticking, and you wanna run something before you let it do that, nexttick is a good choice for that. But you have to be careful, because if you call nexttick recursively, all the microtasks have to be done before you can resume. So if you keep putting stuff like you put process.nexttick on a loop, on a recursive loop, they will never end. So the microtask queue will never end. And that's it. You're screwed because you're going to hog the CPU, you're going to hog the thread, and you're going to block. I want to give you more examples, but we're running very long now, and what it means to block the event loop, and a comparison with Dino, between Node and Dino. Node is mostly written in C and C++, and is using Libuv for an event loop, whereas Dino is written in Rust and is using Tokyo for an event loop. And there are very good videos on Tokyo that I wanted to watch with you, but yeah, we're running out of time. So I appreciate you guys for the time. I hope this sort of clears a lot of what the event loop is like. Maybe I should do like a exclusive video on the event loop just to go more slowly into it, because I kind of went too fast here. So let me know in the comments, what do you want to see? Do you want to see more about BA? Do you want to see more about the event loop? Do you not care how Node works? Thank you guys for your time. Don't forget to leave a like and subscribe, and a comment below just requesting a video if you want to see more about the event loop maybe. I hope you guys have a good one, and it was nice chatting with you.